Welcome to Developer Roadmaps. In this explainer, we're going to dive into something that's at the absolute core of pretty much any web app you'll ever build, how PHP connects to and works with databases.
So, we've already talked about keeping things secure and managing who's logged in. But where does all that user data actually live? Well, that's what we're tackling now. It's time to connect all the pieces, your logic, your users, to the database, which is really the heart of the whole operation.
Okay, here's our game plan. First, we'll cover the absolute basics, making that connection to the database. Then, we'll look at how to make sure our data stays reliable using transactions. After that, we're going to level up with a really powerful idea called Object Relational Mapping, or ORM. And we'll wrap up by touching on some advanced techniques that take your app from a simple script to a full-blown system.
All right, first things first, we have to establish that initial connection. This is the absolute foundation. You've got to get this right.
And it's so true. The database really is your application's long-term memory. I mean, think about it. Every user profile, every product, every single piece of content, it all lives there.
Now, one of the great things about PHP is that it's not picky. It'll happily talk to almost any database you can throw at it. MySQL, Postgres, SQLite, you name it. But, the way we make that connection has evolved a lot over the years. It's gotten way smarter and a whole lot more secure.
These days, you've really got two main options. First up is PDO, which stands for PHP Data Objects. The best way to think about this is like a universal travel adapter. It doesn't matter if your database is MySQL or PostgreSQL, PDO lets you plug your code in just the same. And, super important, it heavily encourages using prepared statements, which is your #1 defense against a nasty attack called SQL injection. Then you have MySQLi. The I is for improved. And just like its name suggests, this one is tailor-made for MySQL. It's all about giving you access to every specific feature that MySQL has to offer.
So, here's the bottom line. Go with PDO when you want flexibility and the freedom to maybe switch databases down the road. Go with MySQL when you're all in on MySQL and you want to use every tool in its toolbox.
A modern connection using PDO follows this idea of prepare once, execute safely. You create a safe template for your query first, and only then do you plug in the actual data. This is what slams the door shut on those SQL injection attacks. And you'll see it's wrapped in what's called a try-catch block. That's just a clean way to handle things if the connection fails, so your whole app doesn't come crashing down. This is the modern standard, for sure.
Okay, so we're connected securely. Awesome. But what about the data itself? How do we make sure our operations are always reliable and consistent? Well, that's where database transactions come into the picture.
So what in the world is a transaction? It's basically a group of database operations that have to be treated as a single, all-or-nothing unit. The classic example is a bank transfer. You have to debit one account and credit another. You can't just do one of those things. The whole operation has to work perfectly, or none of it should happen at all.
And the process is really logical. You start with begin transaction. Then you run all your database commands. If every single one of them succeeds, you commit the changes, and they become permanent. But if even one little thing fails along the way, you call rollback, and it's like none of it ever happened. The database just reverts to how it was before you started. It's an amazing safety net.
I love thinking about it like this. A transaction is a promise you're making to your database. You're saying, look, I'm about to do a bunch of related things. I swear I'll either finish them all or I'll clean up my mess and leave no trace.
And that's really what it comes down to. It's about integrity. Transactions are what keep your data honest.
Okay, now let's talk about a more powerful, more abstract way to work with our data. So far, we've been talking about writing SQL queries. But what if we didn't have to? What if we could just work with our data using the same PHP objects we use everywhere else? Well, that's the whole idea behind Object Relational Mapping. An ORM is basically a super smart translator. It sits between your application and your database. It sees your products table and says, hey, I can represent that as a product object in your code. This means you can manage your data just like any other object, often without writing a single line of SQL yourself.
So before ORMs were common, if you wanted to create a new product, you'd have to write out the raw SQL statement. It's direct, sure, but you're mixing your database language right into your application's logic.
Now, look at the difference with an ORM. You just create a new product object in PHP. You set its name, then you just hand it over to the ORM's manager and say, hey, save this for me. The ORM does all the SQL translation behind the scenes. It's so much cleaner and lets you think from an object-oriented perspective.
And the benefits are massive. You're essentially turning raw SQL into clean, class-based logic. In the PHP ecosystem, the most popular ORMs are probably Doctrine and Eloquent, which is part of the Laravel framework. They're incredible at handling complex relationships between data, and most importantly, they let you focus on building features, not on writing SQL.
And that's the real shift in thinking. An ORM gives your data interactions a clear structure. You stop thinking about individual queries and start thinking about your system as a collection of related objects.
All right, to wrap things up, let's just briefly touch on a few advanced techniques that become really critical as your application starts to scale up from a small script to a high-traffic system.
There are 3 big ideas to keep in mind. First, connection pooling. Creating a new database connection for every single user request is slow and expensive. Pooling just reuses a set of active connections, which gives you a huge performance boost. Second, performance optimization. This includes things like adding indexes to your tables for lightning-fast lookups, kind of like the index in the back of a book, and caching the results of frequent queries. And finally, database migrations. This is like version control, but for your database structure. It lets teams safely make, track, and even reverse changes to the database schema. It's an absolute lifesaver.
You know, once you start needing to think about these kinds of techniques, you've really hit a turning point. Your PHP application is no longer just a script, it's evolving into a robust, professional system.
So, now that your application has a solid foundation for reading and writing data, the next logical step on our roadmap is to really master the architectural side of things, the patterns that make your code modular, scalable, and easy to maintain. And that brings us right to the doorstep of object-oriented programming. Be sure to continue your journey with our next explainer on PHP and object-oriented programming fundamentals. This is Developer Roadmaps. Map your path, build your career.